Hi there, today we're going to be looking at lesson 10.1c, the Pythagorean Theorem application. So the examples we look at today, we're going to be applying the Pythagorean Theorem. Remember, the Pythagorean Theorem helps us to find one of the three missing sides of a right triangle. So in some of the problems today, we're going to be having to find a right triangle. And how do we solve that right triangle in order to help us solve the actual problem we're being asked? So here, let's look at number one. It says, given the square, find the distance of line AD. Well, what I'm going to do is connect point A to point D so that you can see line AD. And there it is. We're asked to find the distance of AD. Now, I don't see any right triangles here, but this is always going to relate back to a right triangle, because one of the biggest standards for 8th grade is using the Pythagorean Theorem. So do you notice here, in order to find the length of AD, I could create a right triangle. Here could be one side. This could also be another side. And then I have a right angle right here. Then I can name the sides. We know that the two sides that make the 90-degree angle are sides A and side B. And then the diagonal side, the hypotenuse, that's side C. And that looks like what I'm trying to find. Well, I have to know two of the three sides. Well, if this is a square and this is the square root of 52, well then side B is also the square root of 52. Both sides are exactly the same here. So let's go ahead and use the Pythagorean Theorem. Side A and B are both the square root of 52. So remember, we have to take side A and square it. There I have it all set up. Now what I'd like you to do is to type in the square root of 52 and then square it in your calculator and see what happens. You can go ahead and pause the video to try this. But remember that the cage and the parrot are opposites. They cancel each other out. So you'll notice that when you typed the square root of 52 squared in your calculator, the answer was just 52. The square root and the squared cancel each other, and I just get 52. Cage and parrot, they're opposites, they cancel. Remember, the goal is to get just the C. So if I add 52 and 52, I get 104. But remember, I just want to figure out C. So in this last step, I'd want to take the square root. Remember, this is a parrot, and I put a cage around it. Same thing to the other side. Well, I know that the square root of 104 is irrational, so I can use a calculator to evaluate that. And when I do that, my calculator says approximately 10.2. So that's the length of C. So if I'm asked for the distance of line AD, I get approximately 10.2 units for the distance. And there we have that one, number one. Here in example number two, we're given a shape that looks like this. We're asked, what is the distance from P to Q? Now notice we have another shape, and these shapes relate to geometry. But the geometry standard for the MCA is using the Pythagorean Theorem. So we're going to have to figure out where are we going to be using that Pythagorean Theorem. Let's see if we can figure this out. What's the distance from P to Q? Well, look at the picture here. Here's P all the way to Q. So we're asked for this entire distance. Well, I know that the length from here to here is the same as this, which is 6. But what I don't know is the distance from here to here. That's the unknown. Well, do you notice here how I could create a right triangle using this part right here? If I trace it, it looks like this. There's the right angle right there. Now what I want to do is to figure out this length. So that's my question mark. But I have to know the other two lengths. Well, I know that the diagonal hypotenuse is 5, but I need to know the length from here to here. Well, slide over. If this entire length is 6, wouldn't just half of it be 3? That would have to be 3, wouldn't it? So now I have 2 of the 3 sides of my right triangle. I just need this length here, because once I find it, I can add it to 6 and find the length of PQ. So what I'm going to do is I'm going to pull out this triangle and draw it exactly how I see it right here. This was 3, this is 5, and this is what I'm trying to find. Remember, the 2 sides that make the 90-degree angle are A and B. So 3 could be my A. This side could be B, the unknown. And then 5 is my hypotenuse. Then go ahead and evaluate. Remember, your last step is to take the square root. That cancels the parrot. Square root of this side, and I get 4. So this unknown side has a length of 4. I'm going to go back up to the picture. From here to here, this is a length of 4. So now do you know the entire length of PQ? Absolutely. From here to here is 6, and then 4 more. 6 plus 4 makes 10. So it looks like we have a length of 10 centimeters. So notice how the Pythagorean Theorem helped us to find that missing part. In our next example, number 3, we're asked to find the area of a parallelogram. Now, you probably haven't found the area of a parallelogram since 6th grade. This was on your 6th grade formula sheet. We still need to remember this by 8th grade. Well, area of a parallelogram, even though I see the shape of a parallelogram, I just still need you to remember that the standard for 8th grade is the Pythagorean Theorem. So somewhere in this problem, we're going to have to apply the Pythagorean Theorem. Always keep that in mind. So let's go ahead and see if we can figure this out. First, we're going to have to try and remember, how do I find the area of a parallelogram? Remember, a parallelogram is just a rectangle. It's like taking, a rectangle and like grabbing these 2 corners and pulling a little bit, just giving a little tug. So if I were to straighten this thing back out again, it would just be a rectangle. So imagine that rectangle just kind of sideways. Okay? In order to find the area of a rectangle, I just take the base times the height. So same thing here. If I straighten this parallelogram out, it would just be, again, base times height. But the thing about the height is that, imagine if you're measuring your height, you stand straight up and down to measure your height, not diagonally like this. So the height is straight up and down here. I'm not sure if you can see it on the video, but there's a dotted line right there. You see that vertical dotted line? So I want to find the straight up and down height. Maybe if I use this red marker, you'll be able to see me kind of trace it. There we go. That's what I need to find. Well, in order to find that height, I could create a right triangle. So notice this right triangle right here. Once I draw it, then you'll notice it. 90-degree angle right here. So I'm going to have to solve the right triangle in order to figure out the height. Well, the 2 sides that make the 90-degree angle are A and B. So maybe we'll call this side A and this unknown side B. And then, of course, the hypotenuse is always C. Let's see if we can go ahead and find that height. I named my A 9. B, in this case, is my unknown, but it could be A or B here. C is 41. Now I'm just going to need to evaluate 9 times 9. And then I maybe want to use my calculator for 41 times 41. All right, so my calculator says that 41 times 41 is 1,681. Now minus the 81. Of course, I know that I have to do my last step here. Okay, square root. The square root of 1,600 is 40 exactly. So here I have 40 as my B, or my height. Okay. So remember, in order to figure out the area, I have to take base times height. So it's hard to see. There you go. There it is. There's the 40 I have there. So the base, this could be the base, right? This 45. or it could be down here, it's still the base. So I got 45 times the height, which is 40. So the area, if I do my calculator 40 times 45, is 1,800. And that's feet squared. There's the area of the parallelogram. All right, our next example is number 4, and I'm actually going to be showing you number 4 twice. The first way that I'm going to show you number 4 is by using the Pythagorean Theorem. The second way is a way that in which a student of mine a few years ago had figured out. I think that you really like it. So what we're asked to do here is to find the area of the blue square. Of course, since I printed this out on a black and white printer, you can't see, but the blue square is this large one, this big square that we have going on right here. Okay, that's blue. So how am I going to find the area of this big square? Well, we know that if we take the length of the sides, side times side, that's going to give us the area. So length times width. But we need to figure out what is the length. Do you see here that this side right here can tell us the length of the large square? So if we find the length of this side, we will know the length of the larger square. So I'm just going to highlight that for you. There it is. This is the side right here that we want to know. How long is this side? Well, there's a smaller square right here. So in order to figure out the length of this side, I could use the Pythagorean Theorem to help me out. So do you see the right triangle? I can solve this right triangle to find this length of the larger square. Well, if this side is the area of the square root of 36, so is this. And these two sides are A and B, which means this is side C. Well, you know that the square root of 36 is 6. So you could just name this a 6 by 6 triangle if you'd like. Let's go right over here and find side C. I told you I was going to use the Pythagorean Theorem. A and B are both these two sides. So here I'm taking the square root of 36. You could just call it 6 if you wanted to, squared. Remember, the goal is to find C. Well, you recall that the square root and square, those are opposites. It's like the bird and the cage. They cancel each other. And I just get 36. Cancel, cancel. Add these two together, which gives me 72. Square root of C, cancel, cancel. Square root on this side. So I get C is equal to the square root of 72. Now I'm not finished yet. I could evaluate this, but I don't quite have to yet. Now C is the square root of 72. So that means this length right here is the square root of 72. So this side is the square root of 72. You know, this side is the square root of 72. This side is the square root of 72. All of them are a square root of 72 because it's a square, and I found one side. So in order to find the area of this big square, I'm going to have to take length times width. Well, if the length and the width are both the square root of 72, it would be the square root of 72 times the square root of 72. Now try typing that in your calculator. If you type in the square root of 72 times the square root of 72, your calculator is going to say 72. It's equal to 72. And that would just be units squared. There's the exact area of the big blue, which you can't see that, the big blue square. Now this is how you would do it using Pythagorean Theorem. But I told you that I had a student a few years ago that came up with a different way. So here you're going to see number 4 again. I think this is so cool. All right, let's find the area of the blue square. Again, the big square. But we're going to do it differently. So remember how the square root of 36 here, that's just 6. This is a 6 by 6 square. Well, think of this whole square here that's inside, right here. 6 by 6. What is the area of this entire square? Well, wouldn't the area of the entire square be 6 times 6, which is 36? Absolutely. So then, let's cut this square in half. I just cut it in half. If the entire area is 36, what would the area of just half of it be? Well, that would be 36 divided by 2, which is 18. So half of it has an area of 18. Well, look at the big square. The big square has 4 of these little ones inside. If this is an area of 18, then this is an area of 18, and this, and this. So how would I find the entire area of the blue square? You're right, add them together. So the area will be just 18 times 4, which is the same thing as 72. Much easier, pretty cool. All right, the next example we have, number 5, we see again another parallelogram. Remember, this is a rectangle. If you turn it, right, it would be straight, but if you just grab these two sides here and pull, you kind of get a parallelogram, just a kind of a tilted rectangle. We're asked to find the length of n. So find n on the picture. Right here. How are we going to find that length? Do you notice how you could use the side n to create a right triangle? Let me highlight it for you. Do you see it? Right up here would be the 90-degree angle. You're right, we could solve for side n by using the Pythagorean theorem. But that means that if n is the unknown side, I have to know the other two sides. So I'm going to need to know this distance right here of this little guy. How are you going to find it? We know that the entire length across the top is 17.25. And the length from just here to here is 13. So let's take this, we're just going to bring it right up. From here to here is 13. And the distance all the way across is 17.25. So what would be left for this little part right here? You're right, you have to subtract those two. And if you subtract them, you get 4.25. So this side is 4.25. So now I have side A and B, the two sides that make the 90-degree angle. I'm trying to find the hypotenuse, side C. I'll just call this little part the A. B. Now your calculator should do all of this for you. So go ahead and just type all of it in, all at the same time. If you do that, your calculator is going to give you an answer, 228.3125, and then it stops. So I'm just going to write the whole decimal. But remember, that's equal to c squared. So now for my very last step, square root this side and square root the other side. Well, if I type in the square root of 228.3125 in my calculator, I get approximately 15.1. And there we have it. That's side C. Remember, our side C was this diagonal side, which the picture labeled n. So we have approximately 15.1. And that's units because it doesn't say what units they're using. And there we solved it. All right, let's take a peek at number 6. Which of the following points is not located 8 units from the point 25? So 3 of these points are exactly 8 units away, but one of them is not. Which one is not? You might be thinking that this is asking us to find the distance between this point and each of these. And you might be thinking that to do that, we might need to use the distance formula. Once, twice, 3 times, and 4 times. Oh boy, that doesn't sound like fun. Not at all. Well, before we start using the distance formula, if we even need to, let's think about where are these points located. I don't have a picture to look at. So maybe what I want to do is to use graph paper or make just a quick sketch to see, could I just look on a graph and see if any of these are 8 units away? Because I might be able to do that. Let's just sketch a quick graph. So we have the point 2, 5. Over 2, up 5. Here's our point 2, 5. And we're wondering which of the points is not 8 units away from 2, 5. Well, do you notice how this x-coordinate has a 2 in it? And these two x-coordinates also have 2's? Did you notice that? Let's take a look and see if that means anything. Let's just sketch where these 2 points would be on the coordinate plane. This one's 2, 13. So that means over 2 and all the way up 13, right here. Well, if this one's at 2, 5, and this one's up 13 to 13 here, how many numbers is from 5 to 13? 8. So wouldn't this point be 8 units higher? Absolutely. It's located 8 units away from this point. So it can't be B. Let's try D. Let's plot this point. 2, negative 3. Over 2, down 3. Now notice the 2 is the same here. Let's go 5 to negative 3. So this one's up here at positive 5, and this one's down here at negative 3. Well, how many numbers are from 5 to negative 3? 5 jumps down, and then 3 more down. Wouldn't that be 8? Yeah, these two are located exactly 8 units apart. Well, then it can't be this one either. Let's try this other one here. Let's try one more. Do you notice how this y-coordinate is a 5? And do you see here that this point has a y-coordinate that's also a 5? Well, let's see if that means anything. Let's graph this point, negative 6, 5. Well, that's back 6 and up 5. Well, how far apart are these points? Well, the 5's are the same, but let's look here at the x. Remember, this is over 2, and now I went all the way back here to negative 6. 1, 2, 3, 4, 5, 6, right? How many units is it from here to here? From here to here is 2, and then here to here is 6 more. That's 8 units apart. Can't be C. So the only one left would be the point 6, 9, which means our answer is 6, 9. It's the one that's not 8 units away. Now what I could do to check it, just to be sure that I'm right, is I could find the distance between these two using the distance formula. I mean, maybe if this question was on the MCA, I'd actually want to take out real graph paper to see that these are exactly 8 units apart. But a sketch just kind of does the same job. So there we have it. I didn't even really need to do any work other than just use some graph paper. And here we are on our last example, number 7. Number 7 asks us to find the perimeter of the figure. Perimeter has the word rim in it. It means the distance all the way around the outside rim of the figure. So in order to find that, I have to add up all the sides. Well, I know this one's 21, this one's 12, this is 30, but I don't know the distance of this one right here. Remember, any geometry question on the MCA is going to have to do with the Pythagorean Theorem because that's the 8th grade standard for geometry. So is there a way that I could use this diagonal side here to create a right triangle? You bet. If I cut the shape right here, I make a right triangle. But in order to find this distance, which is the diagonal side C, I'm going to have to know the sides of these two. Well, from here to here is 12. That means this is also 12. Well, how am I going to find the distance from here to here? Well, this whole part is 30. And from here to here is 21. So if this is 21 and all of this is 30, could I subtract these two? You bet. And then I get 9. 30 minus 21 is 9. So this is a 12 by 9. Let's find length C. I'm going to use the Pythagorean theorem. (144 plus 81). Remember that's c squared. Of course, this isn't the length of 225. So square root, and this happens to be rational. The exact square root of 225 is 15. So we know that c has a length of 15. Remember, that's not what it's asking us, so be careful. You might get this answer 15 and think, oh, that matches A. I'll pick A. But it's not A, because it's asking us for the perimeter. So now we need to add up all the sides. So I have to add 12 plus 30 plus 15 plus 21. I have to add them all up. And when you add them all up, you get a perimeter that's equal to 78 units, which matches with answer B. And there we have it. So just be careful to read the directions, and always keep in mind when you're finished, go back to the question to be sure that you answered it correctly. Have a great day.